Welcome to this video of Maidenhead Bridge. This new video we're going to talk about the CSC Cloud Security Connector PriCPA for Azure. About Maidenhead Bridge. Maidenhead Bridge is a leader in the emerging multi-cloud networking software provider MCNS category. It's a new category. It's the category after SD1. Maidenhead Bridge unites solution let customers connect from any virtual platform and cloud with cloud security connectors for security service edge vendors. And we have a partnership with the two leaders that are Zscaler and Netscope. And we provide connectors since 2016. Maidenhead Bridge has more than 250 customers worldwide, probably more than that, and including government agencies in United States, in United Kingdom, of course, in Germany, in France, in Italy, in Japan, Australia, New Zealand, doing for memory, South Korea, Singapore. We have customers all over India, of course, all around the world. The company, I founded the company. I was member of the first Zscaler SC team in 2009, and I left Zscaler to create this product to solve the challenge when connecting to SEC vendors from public clouds, AWS, Azure, G-Cloud, and on-prem. Maidenhead follow the Unix principle. Do one thing and do it well. It's not a multi-device for everything. It's built for a purpose. Do this task for Zscaler, Netscope, now with PriCPA as a standalone product, and do it well. It's a bespoke solution. About private cloud, private access PriCPA. Private cloud, private access PriCPA is a cloud native solution for WAN communications that covers the scenarios of site-to-site, site-to-cloud, and cloud-to-cloud, following the principles of zero trust. Legacy networking solutions cannot be forklifted to the cloud. There are technical, operational, and security limitations when using legacy solutions. Networking engineers designed legacy networking solutions to communicate branches, central offices, and data centers. Cloud communications arrived with new challenge of networking, security, and mainly operational agility. Applications are now distributed in multiple VNET VPCs of different clouds. APIs are required to be accessed from numerous sites, and we still need to communicate with on-prem services. An agile method of any-to-any secure encrypted communication with zero trust is required. And private cloud, private access is the answer to this challenge. Let's talk about the evolution of the private traffic. How we did the private traffic? Well, I'm a networking engineer, my beginning. I started before MPLS, then I saw TDM, X25, SNA, SDLC, ATM, well, all networking solutions that doesn't exist anymore. Then let's start with MPLS. MPLS, this is still in use, is a solution where the service provider has routers in the border, these PE routers, and in your branch, you need to put a branch route. And MPLS is labeling switching, then has many advantages when talking about private traffic. And the main benefits are it allows any-to-any communication. It's very easy to do any-to-any communication and it scales very well. Traffic engineering, MPLS was the replacement of dedicated links and to try to simulate the same. It provides traffic engineering when you can segregate the type of traffic and to apply a quality of service. And all protocols are supported. MPLS was very good, uh, supporting several protocols to transport. The drawbacks of MPLS, unencrypted, then all traffic is in clear, then that's the first problem. Very expensive because they have SLA and they guarantee the quality of the traffic, then they need to almost secure resources for you, then it's very expensive. Talking about the internet, a single exit to the internet, there was a bottleneck to the internet, and no zero trust. To solve the problems of MPLS, SD-WAN was created. Then SD-WAN has many benefits in contrast to MPLS and some drawbacks. And let's talk about the private traffic. These lines in red when you want to talk between your sites. Then let's go first for the benefits of this SD-WAN is using internet as a transport, and the links are cheap. It encrypts everything, that is good, and all protocols are supported, that is very good. But it has many drawbacks. The first drawback is the one is scalability, because they use IPsec as a transport. If you want to do any-to-any communications, and suppose you have 10 sites to communicate, you will need to create 99 tunnels. Then it doesn't scale very well at all. The other problem is the one that are quite outdated solutions with outdated kernels and unmaintained kernels, and it's a security risk. No cloud friendly at all. The main reason why no cloud friendly is because, well, the design is quite old, and the kernels are old, and it's a myth that on cloud, when you want to deploy something in the cloud, it's like a VMware. The cloud is not a VMware at all. The cloud is completely different animal. You can't deploy simply the same device in the cloud like you can do on VMware. And it's not zero trust because it was not designed with zero trust. If you want to do zero trust, you need to apply policies on each site. Then let's take a look about when you need to communicate now your offices to site in the cloud. What the cloud is offering. The cloud are offering VPN gateways. And the solution, all of them, AWS, Cloud, or Azure, they said, connect to me doing an IPsec tunnels and use BGP. Okay, let's analyze the benefits of this. The main benefits is encrypted private traffic, completely encrypted. That is good. And all protocols are supported because it's IPsec. The drawbacks, the problem are VPN gateways are extremely expensive. If you want to scale, you need to pay more, you need to pay the traffic, you need to pay the VPN gateway per hour, are extremely expensive. And the other problem is the lack of scalability. Again, using IPsec as a transport, if you want to connect 10 sites, that is our example, you will need to create 99 tunnels. This is no way. There's no way to manage this amount of tunnel if you want to do any communications at that moment. If you want this laptop to communicate to this instance and also to this instance, and then you need to start creating multiple communications. It is not zero trust at all, and it's complex to set up and maintain because the lack of scalability. The next evolution of private traffic communications is a service broker cloud. It's a type of clouds that say they have a nodes in the cloud, several nodes in the cloud, and I'm telling you install a connector in your VPC or VNET and also on-prem, and this connector will do a tunnel to a node instance in the country or in another country, depend how big is the service broker cloud, and they offer you a console where you can create the policies and say, I want this machine to communicate with this instance and not with this device. Then this is one way to implement private communications with service broker clouds. Then let's take a look about the benefits. The first is zero trust. Yes, if this, you can select a policy that say this laptop can talk with this instance, but not with this one. The other side is scalability. Most service cloud, broker cloud have nodes all around the world. Some of them run on AWS or G Cloud. I'm not sure, I don't remember to see one, but I saw in the AWS and G Cloud. Then you have presence all around the world, and probably you are able to scale well if you have many sites. The drawbacks of this solution, the first one is very expensive because now, well, the broker is putting an instance in the cloud for you to attend your tunnel. They need to have an internal backbone here to pay the traffic, and they need well to do all management, to pay all the expenses here. That at the end, as a result, it will be something that you will pay. This is an extra overhead you need to pay here for this service. As a result, it's very expensive. We are going back to the numbers of MPLS with this very soon. The second drawback is no support for all protocols. If this machine want to do a ping, normally UDP and TCP are supported, but some protocols are not. Then if sometimes you can want to do a ping from here to here, you will not be able to do it. The third drawback is data in transit is not encrypted. Most people is not aware of this. But if you want to encrypt end-to-end from this machine to this machine, you need to pay an extra license, normally called it double encryption or something like that. But where the data is not encrypted, this connector encrypts to this node instance in the cloud, of course. This is encrypted. But if you do a telnet from this machine to this instance here, inside the broker cloud, the traffic is unclear. Then zero trust principle goes a little bit, not too much zero trust. You need to trust on the service broker because the traffic inside the cloud is unclean unless you pay an extra license. As a result, the fourth problem, problem number 4, poor performance. In general, this is very poor in performance, less than half gig or less. And if you enable double encryption, you want to encrypt end-to-end everything inside, then the performance goes to the half. Then it's very poor in performance, and then you need to deploy multiple connectors, and doesn't scale very well. And finally, everything is all about NAT, all NAT in traffic. If you want in this instance to keep the logs of who was accessing to this instance, you will never be able to see the logs on this server because the only source IP you will see is the local connector of the service broker. Then there is no visibility end-to-end of the traffic. And now our solution that overcomes all the problems we mentioned previously. Our solution, the cloud connector, the CSC, is like in the service broker cloud, is the equivalent of the node instance and the connector, the local connector. Think that the connector is, you can put in half, and half of the connector is dedicated to manage your private cloud now, and the other half is the branch connector for zero trust. What we use to create the cloud is something called a crypto key routing. It's not IPsec. It's not OpenVPN. It's not anything. It's crypto key routing. Crypto key routing is not new. I installed it in the past. I'm talking about well, almost 15, 20 years ago. Proprietary encryptors in government agencies at that time was only the use for high enterprises at government agencies and military agencies. The crypto key routing was in use. And crypto key routing has the advantage that it doesn't need tunnels to be created in advance. Crypto key routing works in the following way. You have a public IP here associated with the subnets that are behind. And when this PC wants to talk with this instance, this CSC will have a table that will say, okay, if you want to talk with this subnet, you need to go to this public IP. And there is a key, of course, there is keys and involved in this communication. Then when the packet arrives to this CSC, for this instance, the CSC will say, okay, I will take a look of the key, encryption key, and say, okay, it's accepted, and it will pass the communication to here. Because this machine is allowed to communicate with this. But this machine, you can create a rule that say, I will not allow to talk with these machines. Then the model of zero trust is guaranteed. The CSC is doing the two components. The main benefit here is savings. There is an 80% savings comparing with VPN gateways or service cloud because there is no infrastructure in the middle here. The only that you need to pay is the CSC. And the CSC is CPA per hour. There's no extra license that you need to pay. There is no extra infrastructure in the middle. It's pure internet in the middle. Then the cost goes down goes down a lot, right? The second advantage is any-to-any communication. Crypto key routing doesn't need tunnels in advance. Then you can put as many sites as you want. And also, it allows you to create more than one PriCPA cloud. For example, you want to create a PriCPA cloud for your APIs, the PriCPA cloud for the contractors, or the PriCPA cloud for your internal traffic. You can create multiple PriCPA clouds depending your application. All traffic is encrypted here, end-to-end. No, there is no limitations. All protocols are supported. It's very scalable. You can put several sites and cloud. It is zero trust. As I said before, this laptop has a rule that can talk with this instance, but then it will not be able to talk with these ones, and the lateral movement doesn't exist. Networking as a code, on the technical video, we will show how simple it is to configure this. It's two-step configuration. In the first step, you onboard the node to the PriCPA cloud. This the first step, and the second step, in a single, only one file, and single JSON file, you will have all the CSCs, all the subnet behind, and the rules, the private apps that you want to get access. Then from a single JSON file, you have your entire rules and nodes. And your task will be to distribute the single file in all connectors and to apply a reload of the file, period. Then everything is DevOps here, and it's completely automated, the process of deployment, of management, or change management. Well, two-step configuration, as I said, onboard the node and deploy the policies in all of them. There is a traffic visibility end-to-end. This instance will see all the logs properly if this machine access to it or any other on a machine. That is very important. You will not lose visibility on the internal instance. Traffic logs, the connector will provide all allowed and blocked traffic. Block lateral movement is a zero trust solution. Then you decide who talk with who. And it's high performance. Each connector supports 1 gig of encrypted traffic without a problem in a very small instance. On Azure, we said if as a start you can use one CPU, 1 gig instant, and is enough. This is the connector on the Azure Marketplace. The model of payment is pay as you go via Azure Marketplace. You don't need to contact us. You go directly to the marketplace, get in now, and follow the instructions. It's very, very simple to install. The only requirement in advance is to have the external subnet and internal subnet for the connector, because the connector is a firewall and we require to have external and internal subnets. And nothing else is required. The price is per CPU hour, and no extra license are required. You don't need to talk with us. You can go directly for the marketplace and to provision the CSC PriCPA for Azure. This is a network diagram of the CSC PriCPA for Azure on high availability. One important thing is when the device is in high availability, nothing else, the CSC will do all the tasks, and you don't need to require extra devices. You don't need load balancers, you don't need nothing. And I will explain in very, 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 very short time how it works. As I said, the connector will require a public subnet and a private subnet to isolate your internal traffic to internal world from the external world. When it's in high availability, the connector, remember we talked about that crypto key routing is the association of a public IP with the subnet behind. Then the connector will manage one IP, public IP that we call a floating public IP. And the floating public IP will be attached to the active connector. This is on the external side. And from the internal side, the connector, this is through Azure CLI, right? It's using the Azure API. And on the internal side, the connector is managing the gateway of the internal routes in multiple route tables. Then you can have multiple route tables and routes inside the route tables, and the connector will say, I am the active connector. The next hop will be my gateway. If this connector goes down, the other one will take the floating IP and will move all internal routers via its own gateway. For this reason, nothing else is required. And again, more cost savings. You don't need to put anything extra to create a high available configuration. Other tools of the connector, well, we decided to use the standard tools to deploy, to manage, to troubleshoot, to see the statuses and logs. If you want to deploy, you can use a resource manager of Microsoft via the Azure Marketplace or use Terraform. If you want to monitor if everything is okay, then node is active, or deploy new policies, you can do it via any change management monitoring tool like Ansible, Rundeck, AWS System Manager. Also, you can use Azure CLI. If you want to use the API of Azure and to run commands, you can do it and to manage the connector. We forgot to put the logo of Azure CLI. Well, if you want to troubleshooting, you can access the console of the connector and to do a TCP dump and to check what's going on with the communication. If you want you have multiple admins, the connector allows you to do radius, and you can apply multi-factor authentication on top of the administration access. Statuses, you can monitor the connector with SNMP and to see the interfaces, CPU statistics, interface statistics, memory statistics. You can see everything. There is no restriction. And if you want to see bandwidth in real time, you can use SNMP, or from the console, SSH console, you have a bandwidth monitor and you can see the bandwidth in real time. And finally, logs is a security devices. Then you can send your logs to the logs collected by the connector to a syslog server, to a SIEM, or to Azure Sentinel to further analysis. Well, this is the end of the presentation. Remember, you can go to the Azure Marketplace and directly search for Maidenhead Bridge, and you will see all the products. Here's the Azure Marketplace. Search for Maidenhead Bridge, and you will see all the products available for Zscaler, Netscope, and this new model that is the CSC PriCPA standalone. As you can see, all other models have PriCPA incorporated, all of them, the Zscaler and Netscope, and this standalone device is compatible with this. Then you can manage, you can connect any to any. Well, thank you very much for your time. I hope you enjoyed the video, and please, if you have any questions, don't hesitate to contact us at at alarsen@maidenheadbridge.com or via our website. And if you have a support case, please go to http://support.maidenheadbridge.com.